Welcome to a new video in our series, A Beginner's Guide to the C Programming Language. In the last video, we learned about compiler directives and how they are used to provide pre-processing instructions to the compiler to create the final source code for compilation. This video will walk through a few standard library functions available in the C language. The standard definition of C provides a large number of functions that C programmers can reuse. These functions deal with standard input-output, memory allocation, string manipulation, math functions, etc. We will learn a few functions in the standard input-output and math libraries. Please share and like this video and subscribe to our channel for more such videos. Now, what is the standard C library? The specification of the C language is defined and maintained by an international organization called ISO. It defines the syntax and semantics of the C language and the library functions that are implemented in the standard C library. While different compiler vendors can add new parts to the language, they have to implement the standard definition of C precisely as defined by the C standard. Thus, the standard C library are functions that are guaranteed to be available within all compilers. As mentioned earlier, they provide useful functionality that can be reused. Besides the standard C library, many vendors offer special purpose libraries with unique functionality like graphics, communication, etc. A C library contains library files with an extension .lib. These files contain the object code of the library function implementations. In addition, the library contains include files with extension .h. As we know, these header files contain function declarations and other symbols. The header files are incorporated into any source file that uses the library function using the #include compiler directive. The lib file is needed during the linker step, where these functions are linked with the object files to create the final executable. Now, there are two kinds of linking: static linking and dynamic linking. Static linking is when the function implementation is present in the library file. Dynamic linking is when the function implementation is present in a .dll file or a dynamic link library. In case of dynamic linking, the linker links a stub function during the link phase, and the DLL file is loaded during execution time, and the function call is performed with the function within the DLL. Today, we will work with four simple standard input-output functions. The standard I/O functions are used for input from the standard input device, that is the keyboard, and output to the standard output device, that is the console. The functions we will discuss are getChar, which gets the ASCII value of a single keystroke from the keyboard, putChar, which displays the ASCII character on the console, printf, which displays formatted output on the console, and scanf, which reads formatted input from the keyboard. Let's look at these functions in more detail. The function getChar gets an int value and does not take any parameters. Hence, the parameter list is defined as void. It waits for a user to enter a key in the keyboard and returns the ASCII value of the key pressed. This function is declared in the header file stdio.h, so make sure you include this file when you are using this function. The function putChar returns an int and takes one parameter that contains the ASCII value of the character to be displayed. It displays the character corresponding to that ASCII value. For example, if the function putChar is passed a value of 65, it will display uppercase A. In the second statement, it is passed the character A, which is the same as passing the value 65. Note that the function is also declared in the header file stdio.h. Next, we will have a look at the printf function. The printf function is an example of a function that takes a variable number of arguments. It takes at least one parameter, and this parameter is called a format string. The remaining arguments to printf are variable and may not be present. This is denoted by the three dots or ellipses in the function prototype. The function printf returns an int value, which we will talk about later. Let us see different implementations of this function. In its simplest form, the function takes one argument, that is the format string. The format string can consist of printable characters, escape sequences like \n, etc., and format specifiers. We will discuss format specifiers later on. What the function printf does is takes each character from the format string and displays the printable characters and escape sequences on the console at the current cursor location. The cursor location is incremented to the next column on the console. As can be seen in the example here, the format string contains only printable characters, so the printf function displays these on the console. Note that the cursor is moved to the next column position after the string is displayed. In the second statement, the format string contains printable characters and escape sequences. The output is shown here. The first character in the format string is a line feed character, so the cursor moves to the next line. It displays the string hello world, which is then followed by another line feed character. So the cursor moves to the next line and then displays my name is. The tab escape sequence then causes the tab character to be output, which is a set of spaces, and then the word Harry is displayed. Note that in both these examples, printf has only one argument, that is the format string. Let us now see how printf can be used to print data and variables. This is done using format specifiers. A format specifier lets the printf function know how the variable should be displayed. It specifies the data type of the variable and optionally the number of columns to be displayed in, the number of spaces before and after the decimal point to be used, and whether blanks are padded with spaces or zeros. The format specifier can also be used to display the data in hexadecimal or octal formats. This table shows a list of a few format specifiers. Note that the format specifiers are encoded within the format string argument of the printf function. For each format specifier in the format string, there needs to be a corresponding argument in the variable list of arguments following the format string. Let's have a look at some examples of the printf statement using format specifiers. Here we have a printf statement that prints the value of different types of variables. The first statement displays the value of an int variable inum. It first displays the value and then displays the value of inum in four spaces, which is zero padded. The second statement displays the value of inum in the hexadecimal format. We use three format specifiers and pass the value of inum three times as parameters. The first format specifier displays the value of inum in hex with lowercase. The next displays the same value in uppercase. The third is zero padded. Similarly, the next printf function displays the float value in variable fnum. The second format specifier specifies that the value should be displayed in 7 columns, 4 before the decimal point, then the decimal point, and 2 places after the decimal point. As you can see, the number is displayed as 10.20, where previously it is displayed as 10.2000. Finally, we will display the character variable as a character using the format specifier %c. We can then display the same character as an int value using the format specifier %d. Let's have a look at how this works practically. We have written the same examples as shown earlier. Now, when you execute a console application in the IDE, it first displays a console window. All user input and output happens on this console window. Let's build and execute a program by single stepping through each line of the code. The console window is initialized and displayed. The control goes to the first line of main. Let's execute the printf statement. Notice that it displays hello world and the cursor is to the right of the last character of the string. We now execute the next printf function. Now the string hello world is displayed in the next line because of the line feed escape sequences that precede it in the format string. The following string, my name is Harry, is displayed in the next line with a tab before the word Harry. Then we display the value of inum both as a value and a zero padded 4-digit value. The next printf statement displays the value of inum in various hex formats. Now we display the value of fnum without any formatting as well as with formatting specifications in the format specifier. Finally, we display the value of uppercase C as a character and as a number containing its ASCII value. Notice how each printf statement outputs its data to the console. When the program ends execution, the console displays a message informing you that the console is no longer required. Press a key on the console to terminate the console. The function printf is used to display output to the standard console device. The function scanf is used to input data from the keyboard. Just like printf, the scanf function takes a variable number of arguments. These are specified in the format string, which specifies the type of data to be inputted. The argument list is the address of the variables that will contain the data that is inputted. Scanf is an example of a function called by address. The address of variables is passed to the function. Its address is then used to indirectly modify the variable. As shown in the example here, the first scanf function waits for a value to be entered on the keyboard, followed by the enter key. The data value entered is then formatted as an integer value and stored in the address of inum, which causes inum to be initialized with this value. Similarly, the next scanf function enters the float value and stores it in the address of fnum. Finally, we'll display the value of inum and fnum, which is the value entered from the keyboard. Let us see this in action. This is the code we just discussed. We execute the code. When the scanf statement is executed, we enter an integer value and press enter. Then when the next scanf function is executed, we enter a float value and press enter. The printf function then displays the value of the two data items that we have entered. Then the program exits. Note that both printf and scanf return an int value. This int value for printf is the number of characters it has displayed on the screen, whereas scanf will return an int value that specifies the number of format specifiers inputted correctly. For example, if the user does not enter a numeric value but some alphabetic characters instead, the scanf function will immediately exit, even if more data needs to be entered. The return value will specify how many input variables were inputted correctly. So we have reached the end of this session today. We had a look at library functions in the standard input-output library in C and seen how to call these functions in your program. We understood their functionality and explored different versions of the same function. Please follow our channel, like and share this video. In our next session, we will see how to use the debugger in the IDE. The debugger is a very useful tool for experienced as well as new programmers. Understanding how to use the debugger will accelerate your development activities and also help you learn the C language faster. See you then.